Okay, so the last part of the systems of equations is going to be doing the application where we're combining all of the different parts of what we've already done. So we know that we have three methods for solving. We can either graph, we can substitute, or we can eliminate. Remembering that if it specifies that we're doing it algebraically, that just means elimination or substitution. When we're problem solving, we can solve a variety of types of problems using a system of equations. There's four general steps. Step one is we need to introduce the variables and then state what they represent. Step two is we're going to create the equations. Step three is we're going to solve the system. And then step four is we're going to answer the problem and then check to make sure that our solution makes sense given the context of the problem. So, for the first one, we're dealing with number applications. It says the difference between two numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. Well, the first thing I need to do is state what I'm trying to find. So in this case, I'm going to say that I'm going to use L and state that it represents the larger number. And I'm going to use S and state that represents the smaller number. This is what we call defining variables. Now, if I know that L represents the larger number and S represents a smaller number, I'm going to split it into the two sentences and say, well, sentence number one is going to tell me my first equation. It says the difference between the two numbers is 9. So I can say that the larger number, difference mathematically means subtract. Subtract the smaller number is going to equal 9. There's one equation. Then I'm going to use the second sentence to create my second equation. The larger number is 3 more than twice the smaller number. Well, for my second equation, I'm going to say the larger number. As soon as I see the word is, I know what that means it's going to be equals. 3 more than twice the smaller number, well, twice the smaller number is going to be 2s, and 3 more than that is going to be plus 3. Usually the part that we find the hardest is actually just creating the equations in the first place. Now, I can use one of my methods in order to solve this. And in this case, I already have L is isolated in equation number 2, so I'm going to use substitution. I'm going to substitute the value of L in equation 2 into equation 1. And I'm going to say that for equation 1, I have 2s plus 3 minus s is going to equal 9. Well, 2s minus s is going to leave me with s, and I'm going to subtract 3 from both sides to move that across the equation. And I can say that, in this case, it looks like s is equal to 6. Now, I'm going to take that and put it back into my second equation and say if L is equal to 2 times 6 plus 3, then L is going to equal 12 plus 3, or L is going to equal 15. I can double check it. Well, 15 minus 6 does equal 9, and if I double 6, which is 12, and add 3, that's going to equal 15. So I have my answer. The two numbers are 9 and 15. The next case it gives us is going to be a perimeter question. It says the perimeter of a rectangle is 40 meters. The second part is it states that the width is 4 meters less than the length. Find the dimensions of the rectangle. Well, I mean, I'm going to use the standard variables here. I'm going to say that W represents the width in meters, and L represents the length in meters. I'm going to get my first equation is from the first sentence. The perimeter of a rectangle is 40 meters. Well, I know that a perimeter is going to be 2 lengths and 2 widths, so I can state that my first equation is going to be 2 lengths plus 2 widths is equal to 40. My second equation, which I pull from the second sentence, the width is 4 meters less than the length. So I could say that if the width is 4 meters less than the length, then the length minus 4 meters is going to equal the width. I also could have said the width plus 4 was equal to the length. Doesn't really matter. And because I have a variable isolated again, I'm probably going to do substitution again. So I'm going to state that from equation 1, 2L plus 2, well, W we know is L minus 4 is equal to 40. 2L plus 2L minus 8 is equal to 40. 4L is going to equal 48, where L is going to equal 12. Then I'm going to put it back into my equation 2. If my width is the same as L minus 4, or in this case 12 minus 4, then my width is going to equal 8. I could always double check this. Well, the width is going to be 4 less than the length. If the length is 12, then 4 less than that's going to be 8. And at the same rate, if I took 2 times 8 plus 2 times 12, that does give me 40, so the numbers make sense. So then I'm just going to state that the width is 8 meters and the length is 12 meters. And there's my dimensions.